morning, ladies and gentlemen. My name is Jim Watson. I'm the Director of the Bureau of Safety and Environmental Enforcement at the Department of Interior. And it's my pleasure this morning to introduce the Secretary of Interior, Secretary Ken Salazar. And I just want to say a few words about his leadership in my experience working with the Department of Interior, which actually began in the relationship we had during the Deepwater Horizon disaster. As a Coast Guard officer at the time, I was very involved with the response. But needless to say, we needed leadership at the very top of the Department of Interior in actually solving this problem. Otherwise, it was going to be a long, long cleanup. Well, the Secretary came to town in New Orleans, where I was. He is definitely a take-charge guy. He initiated the investigation. He initiated a series of fundamental improvements based on analysis, based on scientific work done not just by his own department, not just by the U.S. government, but using all of the resources that we have as a nation and that we have as a cooperative community of people working in the offshore. So today, we're going to focus on just one element that came out of the many studies that have occurred and the analysis that has been done, and really build on improvements that have already been made, but recognizing that we're not finished, that we're going to need to continue to tap the talent, continue to tap the engineering skills. Drilling in the offshore is going to continue to be more challenging in the future than it has been in the past. And so I want to bring Secretary Ken Salazar up and give us a few remarks, and please pay close attention to his leadership. He's terrific, so thank you.
Thank you very much. Thank you very much, Jim, for the introduction and for your leadership of the Bureau of Safety and Environmental Enforcement, and to Dr. Tom Hunter. Thank you for your leadership, not only during Macondo and the solutions there, but your continuing leadership of the Ocean Energy Advisory Committee. And to Chris Smith from the Department of Energy, thank you, and Secretary Chu for your able assistance and help on all the work that we do on energy. And to my Deputy Secretary, David Hayes, thank you for the work that you do on so many different fronts. And then to all of you who are here, thank you for coming today and being a part of our continuing efforts to try to make sure that what we do with respect to ocean energy and oil and gas drilling in America's oceans and really in the world is a gold standard, and one that both the government, the industry, and the stakeholders, including the conservation organizations, can be proud of and can be sure that we are doing oil and gas production in America's oceans in the safest possible way. Let me first say that if you back up and you ask yourselves, what is it that we are doing with respect to oil and gas in America, and what are we doing with oil and gas in the oceans of America? I want to make sure there is no doubt in this room as I say the following, and that is that oil and gas is very much a part of President Obama's energy portfolio. And when we speak about the all of the above energy program for the United States of America, we do have a significant part of that that is very dependent on our continuing to produce as much as we can domestically with respect to both oil and with respect to gas. And the statistics themselves, I will not go over all of them today, but there is a lot that's happening both on the onshore as well as on the offshore with respect to oil and gas production. Now, as we do it, all of us here in this room are assembled here to focus in on the BOP because we know that that was one of the areas of intense focus during those days of the Gulf oil spill. And we were all trying to figure out for so long what it is that could be done with respect to the BOP, and then when the conclusion was reached that there was not much we could do with the BOP, how it was that we should move forward with the capping efforts that ultimately succeeded. But there's no doubt for all of us who lived through those 87 days of the 50,000 barrels or so a day spewing out into the Gulf, that we had an intense focus on what was happening with that BOP and what it is that we could do. I remember well the meetings which Tom Hunter and Stephen Chu, Thad Allen and I and other members were a part of, where we asked ourselves lots of different questions. Why is it that we don't have the kind of sensors and gauging capacity so that we can understand what's happening inside of that BOP? How about the remote actuation of BOPs? How about the possibility of having another set of shear rams? Could that maybe have prevented it as we started looking at some of the results from some of the investigations? But there were all those questions that were being asked. And so today's forum really is an opportunity for us to try to move forward, to engage you with your best thoughts on what we ought to be doing with the next generation of BOPs. And you'll hear not only from the experts who are up here in this panel, but you'll hear from other people throughout the day. I want to make a comment just about the Gulf of Mexico, because after all, the Macondo well was located in the Gulf of Mexico. Today, I'm proud to report that some 2 years and 1 month after the beginning of the oil spill, that the Gulf of Mexico is back and is producing oil and gas and is exploring for oil and gas in a very robust way. Some people probably thought at the time that the Macondo well oil spill was going on that we may just have to shut down oil and gas production from America's oceans for a long, long, long time. And yes, we put a pause in place for 6 months to make sure that we could do a lot of different things that needed to happen in order for us to get to a point where we could be comfortable assuring the American people that we could safely produce oil and gas in the Gulf and other places. But we're back, and the statistics, I think, say it all in the following way. We are producing about a third of all our domestic oil from the Gulf of Mexico today. The number of rigs, as we speak here, is now at a higher number of rigs working in the Gulf of Mexico than they were on average during the year of 2009. So the rig activity in terms of drilling is actually higher today than it was on average throughout 2009. In the last 12 months, under Jim's leadership and Tommy Boudreau's and other people in those bureaus, we've issued more than 60, I think it's number 67 permits to go into the deep water. So we're moving forward with a permitting program that is a good permitting program. And importantly, we should signal to all of you who are watching that we are moving forward to make oil and gas acreage available in the Gulf of Mexico and elsewhere. And so this last December, we held the first lease sale, which I attended in New Orleans, which was a record lease sale for the Gulf of Mexico. And it was the first lease sale after the Macondo oil spill. In June of this year, so in just about a month, we will be holding a second lease sale. And it will cover both the central and the western Gulf of Mexico planning areas. And the amount of acreage that will be made available again for companies to come in and bid on is somewhere in the neighborhood of 38 million acres. So 38 million acres will be made available. And we've not just done that work in terms of moving forward with trying to make sure that we're doing everything in a safe and environmentally responsible way, but we've moved forward in some other important policy issues in the Gulf, including the negotiation, which took place over a 2-year period, to finally resolve issues which had been outstanding for a very long time with the nation of Mexico. And that was the creation of an agreement between the United States and Mexico that resolves the transboundary issues in terms of how we develop those areas along the transboundary, which is a significant addition for potential development of oil and gas in the Gulf. And in addition to that, besides resolving the border issue with Mexico and the Gulf, when you look at the Gulf, as I have so often in my time in this job, it really is one pond that we share with the Mexican nation. And we can do all that we want to do on this side of the border, but unless the Mexican authorities are able to do what they need to do on their side of the border, we will never be safe here in the United States. And so part of what we have done is to engage in some very robust dialogue with the Mexican nation, where they essentially are following the protocols that we're developing here in the United States. And as you look at the Mexican economy and the Mexican nation, they will move into the deeper waters because they have had significant declines in oil and gas from their current reserves and their shallower waters. And as they do so, it's important for us to make sure that the kinds of standards that they're going to employ are going to be the kind of standards that we are very comfortable with. So today, as you look at the question of the BOPs, I would only ask you to make sure that what we're doing is the very best that we can here in the United States, in the areas that we govern, and the areas where many of your companies drill for oil in the oceans. But I would also ask you to reflect on the fact that what we do here is very much a part of the global industry for oil. You know, what we do here is really not going to be much different than what gets done in lots of other places, including Nigeria and Norway and so many other countries that are now drilling into the deep water. And so for us, in June of this year, the last part of June, we will be holding the second International Containment Forum, where we will bring together a number of different countries meeting in Norway, where we will discuss the same issues that you are discussing here today with respect to the blowout preventers. So in conclusion, the way that I see our work here at Interior is within the policy initiative of making sure that we are developing our domestic resources as robustly and as responsibly as we can, that we need to make sure that the lessons from the Deepwater Horizon and the Macondo oil spill are not forgotten. And so for us, in our efforts with Jim Watson and with Tommy Boudreau, what we've done is we've said we have to do everything we can to prevent oil spills. And so the drilling standards that are now in place, the workplace standards that are now in place, other efforts which Jim Watson and Tommy Boudreau have instituted, they are making us get to that point where we hopefully will prevent one of these things from ever happening again. But I always remind people we can never be cautious enough, because you remember those days before April 20th where people would say there were 60,000 wells that had been drilled in the Gulf of Mexico. You can't have an oil spill like the ones that they had in Ixtapa or other places around the world. It's not going to happen in the Gulf of Mexico. Well, it happened, and we don't want it to happen again. But knowing the lesson also of Macondo, that it did happen, we need to make sure that if it does happen, that we're ready to move in quickly. And so containment becomes a major priority for us as we deal with the development of oil and gas in the Gulf of Mexico and in other oceans of America. And so in the coming weeks, months, you will see actual dress rehearsals of companies that have been set up in order to be able to respond quickly to a Macondo style kind of incident. So you have the prevention, you have the containment, and then the third leg of the stool is what do you do with the oil spill response itself in the event that you do have an oil spill. And that too is being addressed by Jim Watson and his people. So let me finally just say this. We have had 3.5 years of working through some difficult times, yes, here in the United States. But I'm very confident about our future. And I'm very confident also about oil and gas being an essential part of the future economic wherewithal of the United States. And one of the reasons that I'm so confident that we'll be able to do right is because of the leadership that we have been able to get at the Department of Interior. David has been with me from day one, but I still remember on the day of April 20th when I put him on a plane to head to New Orleans to see what was going on with the rig that was on fire. And he's been with us every step of the way. Jim Watson, who spent so much time in the Gulf of Mexico leading on the front lines as we dealt with that national crisis, which is a unique national crisis, but which had the focus of the entire nation, now is leading our Bureau of Safety or Energy and Environmental Enforcement. Jim spent 30+ years in the Coast Guard as an admiral, so he knows these issues. He essentially is a cop, making sure that it is getting done right. And then Tommy Boudreau, who I know you will hear from later on today, is a part of the organization that basically does the planning. So he's the one who plans. He's the one who decides we're going to hold this lease sale in June of this year in the Central and Western Gulf. And he's the one who's planning out for places on the Atlantic and places on the Arctic and other places. So We have a great team of people, and I look forward to the dialogue with this panel, as well as to the results of your forum today. Thank you all very, very much.
It's also my pleasure this morning to introduce David J. Hayes, the Deputy Secretary, U.S. Department of Interior. As the Secretary mentioned, David Hayes was confirmed in 2009 and by unanimous vote of the United States Senate and came into the Department of Interior along with the Secretary. And so he is the second highest ranking official in the Department of Interior, and by statute, he serves as the department's Chief Operation Officer. Among his many things, and he is a true leader, he is in charge of promoting all the conservation initiatives within the department and across our great country in the public lands. This includes the President's America's Great Outdoors agenda, encouraging renewable energy development, developing our conventional energy resources safely and responsibly, fulfilling our trust to the American Indians and Alaska Natives, and managing our nation's water supplies in a sustainable way. In 2011, the President appointed David Hayes to chair the Interagency Working Group on the coordination of domestic energy development and permitting in Alaska. And this is a work to organize the federal agencies to oversee the responsible development of onshore and offshore renewable and conventional energy in Alaska. And believe me, he has really taken that to heart and has done a terrific job. And so I'd like to welcome this morning to the podium the Deputy Secretary, David Hayes.
Good morning. My primary responsibility here this morning is to moderate the first panel. I want to make just a couple of quick introductory comments. First, to amplify a couple of points the Secretary made as to why we are here today. We are here because we want your help in putting together the best proposal for a new regulation governing blowout preventers. Our plan had originally been to go slower and to do an advance notice of proposed rulemaking that would have opened the doors to ideas of all kinds that are certainly welcome, but that would have taken many months before we could get to a proposed rule. Under Jim Watson's leadership, we made the decision that based on the information we had from the Macondo well situation, and the potential expertise that we would gather today with your help and in the days to come, that we should not wait and go through an advance notice of proposed rulemaking, but instead go to a proposed rule that obviously would be open to public comment as well, but that would get us quicker to a new regime for blowout preventers. So we're looking forward to today's workshop to help us in that regard. Secondly, we have a good idea of where we want to go with blowout preventers. Last night, I was reviewing again the National Academy of Engineering report on the Macondo well incident. Don Winter is here, the chair of that esteemed commission. That report, along with the joint investigative report that was done by the Department of the Interior and the Coast Guard, point very clearly to some serious issues that were associated with a blowout preventer situation on the Macondo well, issues that were not limited to the Macondo well. And I would suggest that as we reflect through the day, there are at least 4 things that we're looking for in a new proposed rule. One, BOPs need to be able to cut whatever is in their way and completely seal off the well. Number 2, we need better maintenance for BOPs, like what you would expect of a jet engine or any other very sophisticated mechanical device upon which lives depend. Number 3, BOPs need better sensors to tell us what is happening at the bottom of the sea. And number 4, everyone working with BOPs should be fully and properly trained to handle any contingency. It, of course, is not quite that simple, which is why we have the panel here today, to talk about the technology lessons that we've learned from the Macondo well situation as a prelude to a fuller discussion about where we should go with regulating blowout preventers. I'm going to introduce the 3 panelists and ask them to give their remarks. After each of their remarks, at the end of their remarks, we'll have a Q&A with the time remaining. First, Jim Watson. The Secretary mentioned Jim Watson's terrific pedigree. He is new to the department as the Director of Bureau of Safety and Environmental Enforcement, being sworn in December 1, 2011. He is not new to this field, as you know. Prior to his appointment, he served as the U.S. Coast Guard's Director of Prevention Policy for Marine Safety, Security, and Stewardship, where he was responsible for maritime investigations, inspections, waterway management, commercial vessel safety. As you know or may know, he served as the Deputy Commander of the Coast Guard Atlantic Area Command in April 2010 to June 2010, and was the on-scene coordinator for the government-wide response to the Deepwater Horizon oil spill in the Gulf of Mexico in 2010. He's an engineer, a graduate of the U.S. Coast Guard Academy, also has 2 Master of Science degrees from the University of Michigan, one in mechanical engineering, the other in naval architecture. We're very fortunate to have his leadership. Tom Hunter will be the second panelist. He is the chairman of the Secretary's Ocean Energy Safety Advisory Committee. We are very fortunate to have had Tom's service. He was the chief science advisor throughout the Macondo well incident. At the time, he was president of the Sandia National Laboratory. Stephen Chu brought him in to head up the science team. He was absolutely instrumental in helping us work through that crisis. Despite the fact that in theory he is retired, he has never failed to serve all of us and this country, and has been putting in enormous time as the head of the Ocean Energy Safety Advisory Committee, which has done excellent work in helping chart the next path, the path forward for all of us as we look at improving deepwater oil production safety. And finally, Chris Smith is here. Chris is the Deputy Assistant Secretary for Oil and Natural Gas at the U.S. Department of Energy. DOE is a key partner for us at the Interior Department on all of these issues, and Chris also has been with us every step of the way. He served, for example, as a designated federal officer for the National Commission on the BP Deepwater Horizon oil spill and offshore drilling. Prior to his appointment to this administration in October 2009, he spent 11 years in the private sector with 2 major international oil companies. He also is an engineer, having received his BA at the United States Military Academy at West Point and an MBA from Cambridge University. So without further ado, I'll turn it over to Jim Watson, followed by Tom, and then Chris. Thank you.
Safety at all levels, for me, means from the bottom of the well to the top of that derrick. And we at BSEE have one mission, and that is to ensure the integrity of that operation that goes from the deepest depths to which we have to have exploration and production of our nation's oil and gas resources offshore to the delivery point back on shore, where that's going to be handled in a downstream way. But for me, the safety at all levels also includes all levels of our organization. We need to have an outreach program. We need to have a safety culture that begins at the boardroom, begins at the executive level, and actually reaches down to each and every person out in these offshore operations. There has to be a real meeting of the minds, and this has to go across the industry, among the contractors, among the government role, and certainly among the corporate levels of the industry. And all times is tremendously important. We can't just have safety when the inspector's there. It can't just be a snapshot safety. We have to have some confidence that it's just as safe, just as tightly managed, tightly controlled, tightly monitored, 24/7, 365 days. Every one of these operations offshore has to be safe at all times. Now, the offshore petroleum industry is a dynamic industry. It pushes into new frontiers, both on the exploration and production side. I've seen that just since coming here in December, and this is going to be continuing forward in the future. The Bureau of Safety and Environmental Enforcement has to get in front of this, of a learning curve, has to get in front of this evolution of development, for exploration, for production, and we have to be leaders. And this is one of the ways you get to be a leader. You bring people together and you listen to them, the people who have most at stake by the results of our leadership. Now, since the Macondo incident, we've really had one of the most aggressive and comprehensive offshore regulatory reforms in the history of our country. And I'm going to touch on that a little bit more in the next slide. But among the technologies that are essential, and we've heard both the Secretary and the Deputy Secretary talk about this, for the continued effort of our offshore exploration is the next generation blowout preventer and the control systems and all of the technology that goes into the design and the fabrication and the testing and the monitoring of these systems. And then we have to have the management regimes, and we have to have the regulatory processes. There is an important role for the U.S. government when we're leasing our outer continental shelf for this kind of activity. And so let me touch on the accomplishments that we've had just since the Deepwater Horizon casualty. The drilling safety rule. This rule was done as an interim final rule. It was done in response to the 30-day report that was delivered to the Secretary. And it actually includes some very important blowout preventer improvements that are in place right now. The Bureau has been doing substantial work in monitoring the implementation of the drilling safety rule with regard to blowout preventers, cementing, and other things. Among the other rules that have come into place is the workplace safety rule. The safety and environmental management system is now in our regulations, and companies have been begun to audit themselves on the implementation of this rule, and we are beginning to do our role in the oversight of those auditing operations. And you can read the rest of these activities, the well containment program, the growth that's been necessary, along with the modernization of the functions that used to be MMS into BOEM and BSEE and Honor for the revenue collections. And we've also instituted a new training program, not only for our inspectors, but for our petroleum and other engineers who are so critical to issuing these permits that are so necessary to do safe and sustainable development in the Outer Continental Shelf. So what have been the new BOP requirements to date? Well, first of all, third-party verifications of the capability of the blind shear rams and the BOP stack itself, that it is going to be working in accordance with the regulations and in accordance with API RP53 and the best practices of this industry. In addition to that, there were requirements for subsea secondary intervention with ROVs that we test on a stump test before the BOP is put into service, as well as a bottom test within a specified period of time following the deployment of each BOP to test those blind shear ramps. And then also we have crew training requirements. We want people offshore who know how to use this equipment, who will use the safety equipment. This is a man in the system. So we have to make sure that the people are up to the task of actually using the equipment properly and making sure that it's operating at all times and all levels the way we expect it to be. And then, of course, when you have a third-party system, you have to establish the qualifications for those third-party people that you're relying on to do that oversight work. So we have written requirements, and then we follow up as a bureau to make sure that each of those third parties is actually capable of doing what we are expecting them to do. So what's ahead? Well, just in this first year, we will first see a final drilling safety rule. This would incorporate all of those comments and some experience that we've had since the implementation of the interim final rule, now almost a year and a half, 2 years later. And there will be some minor improvements to that rule. In large, the standards that we've established in the interim final rule are going to be continued moving forward, and that rule will be out very soon. We also plan to have a final SEMS 2 rule. Now, we had a SEMS 1 rule that basically made reference to API RP75, which has actually been an industry practice for years, and we have seen good results from that. We put out some additional proposed rules to augment the SEMS 1 rule, and those things were out for public comment. We got some good comment, and we hope to very soon put out the final rule implementing the appropriate elements of SEMS 2. And then there's the rulemaking that Deputy Secretary Hayes mentioned, Secretary Salazar. We're going to go to a notice of proposed rulemaking, largely based on the input that we get here and the input that we've already received from the many analysis of the BOP status in the state of the art right now from experts throughout the industry, throughout government, and go straight to the notice of proposed rule for a next generation BOP. And then we also, in my committed desire to not just fight the last war, we are looking at what are the risks on the production side, and there are some, and we are going to address those in this calendar year with a proposed rule on the production safety systems, and we intend to introduce this life cycle analysis concept into our standards. That's that all times piece.
I'm going to spend a little time showing you a couple of slides, then I'm going to ask you some questions. You don't have to answer them, but I'll ask them in any case. I was asked to do a short bio for this, and I submitted one, but if you really wanted to know the real short bio, it has one simple word in it. It says unemployed. And so I was going to mention I learned a lot from Macondo. It's a great experience. I learned that heroic things can be done when people work together, and I learned to meet some very trusting and important friends in a very dire conditions. What I did not learn is to avoid any further assignments from those friends. However, I'm going to spend today and talk a little bit about the Macondo experience and not go over too much what the other panels are going to talk about. But let me begin with the first slide as a way of introduction myself. Deepwater drilling is not the only place where high integrity, high response systems are used. This is a picture of what I call a real closure system. It weighs 90 tons. It has two 4,000-pound slides. It holds 15,000 PSI pressure. And the most important thing about it, it closes in 15 one-thousandths of a second. It was actually used in underground nuclear testing. I use it in introduction because the person on the right, regrettably with the pocket protector, is the speaker, as one of the designers and patent holders. So complex systems are not new. They're used in many places, and blowout preventers certainly meet that test. What I'd like to do, though, is then give you a few slides of the Macondo BOP. I should say Deepwater Horizon BOP. And then I'll ask you some questions. And the slides I'm going to show you are going to tell you everything you need to know, everything you're going to get to answer these questions. There's no more information. And you see how well you can answer the questions. So here's the beginning. This is the flex joint near the top. And the joint just above is where the capping stack was placed. This is the beginning of the LMRP, and you're going to go down through the pods, cover the two pods that were there. Then we begin at the lower part of this picture. You'll see the blind shear ram, which was the ram intended to do the real closure. Following that is the casing shear, and following that are the variable bore pipe rams, which go immediately below that, and then below that is the H4 connector, which is right above the mud line. Well, this is what we had, if you recall, Mr. Secretary, in the first week in May. And it turns out that we had a lot of questions, and I'll share those with you. First of all, does the data and the drawings that we have match the system that's undersea? Secondly, what are the positions of the rams? Are they closed, open? Are the locks set? What, if anything's inside the bore? What are the pressures all along this stack? Are there any flow restrictions anywhere inside the stack? Are all the controls hooked up? Is it stable? That is it going to tip over? And will it separate or come apart if we try to do that? And lastly, what is the flow going through the bore and through all the closed rams, or whatever position they're in? I can't tell you how difficult, if not impossible, it was to find that out. The best diagnostic we ever had was when the capping stack and then the BOP was pulled off of the well. Then you could observe the pipes inside. You get a sense of what happened with the BOPs. We spent countless hours trying to understand what was happening with this system, and never had anything more than guesses on many of the potential features, and never could diagnose things like the flow until the capping stack was in place. So the point is, it was not a self-revealing system. It was just very hard to understand, and the data we needed to do the response was not available. So what I'd like to turn to is talk about the functions of blowout preventers and some of the learnings that I personally had from that experience. So let me list them in kind of terms of the phases of the function of a blowout preventer. And I'll use adjectives or adverbs to kind of describe characteristics, and then try to summarize in closing what an ideal blowout preventer would have as characteristics. First of all, in pre-event, which is when it serves its normal function, when it's used in the drilling operation and before any kind of event, even if the event is as minor as a kick or some kind of response that has to be done by the rig, the blowout preventer should always be available. That is, whenever you push a button or send a signal, it should be there. It should be self-assessing and diagnosing. It should tell you, much like your car does, if you have a problem with the ignition system. It should tell you something is wrong with me, and I know what it is, and I'll tell you what it is. It should be repeatable. That is, when you do it many times, it should get the same response each time. It should be upgradable. That is, it should be able to have enhancements if necessary and if done safely. It should be repairable. It should be understandable. You can't have all kind of complicated things that drillers and people can't understand when they have to operate. It has to be something that fits into the drilling operation and understand how it functions. And of course, it should be affordable. If there is an event, either a small event or a major event, there are some characteristics which I think would be desirable. First, it should be instantly responsive. There shouldn't be a lag time or a latency between the time you act and the time you get a response. Secondly, it should be controllable. I'll remind you that it's not clear, even though we attempted to do it in the early days of the Macondo well, to shut the well in. It's not clear that's the right thing to do and at what pace you might do it. You might want to do it slowly. You might not want to, the well could be damaged, or you may damage the well, so you have to have some controllability on how you might shut in the well. You have to have full communication with the device. You have to be sure that whatever function you send down, whatever intent you have, is the function it performs. You can't have cross wires or different signals or things that don't work together. And then everything you do has to be correlatable with the diagnostics that you have. That is to say, if it says you need to have a certain response or action, you need to be able to do the corresponding action. Now, if there is a major event, which we, of course, experienced 2 years ago, there are some things that I think a blowout preventer can provide. First of all, transparency. It should be clear what's going on. And one should not have to go through the days, if not weeks, of trying to understand the situation. All the elements should be fully diagnosable. And all the internals should be observable in some way. There should be opportunity for flow measurements and pressure measurements, temperature measurements, all the things which allow you to do a full diagnosis. And finally, if there's a containment exercise like we saw in Deepwater Horizon, where you actually choose to collect hydrocarbons over some period of time, there should be some measures of flow control, and there should be some redundant self-capping availability, which means there should be some way that if you decide you can do it, that you can always get an additional complete closure. And I would add to that as we go through that there should be a concept called shear certain, which means that if you have obstructions in the way, you have to have a way to be sure you can clear those obstructions and get closure. Well, if those are the functions you want, I would really encourage that we come up with some fundamental design principles. One of my previous roles was I had to write a letter that went to the president each year that said, this is the assessment of safety of the nation's nuclear weapons. And in that process, we always had fundamental principles of safety that we use, which were on everybody's mind. But let me list a few that one could put for a blowout preventer system. And by the way, I view blowout preventers as a system, not just rams, but all the things that go with a blowout preventer. There are accumulators and communications and disconnects and pods and hot stabs and access points and all the things that are within a blowout preventer. So I think it's a system framework, and I always assume that's the way the design problem is approached. But let me just close by listing a couple things that one might choose on which to base some design principles. One, it would be 100% available. That means at all times it's ready to do its desired function. Two, it will be totally controllable. That is, at any time, you have the ability to make an intent turned into an action. Three, it would be completely diagnosable, which means all those questions which I listed, which none of us today could answer from looking at those pictures, or which we could answer in the first couple months of Macondo could answer. All those diagnoses could be done. Four would be what I call shear certain, which means if you need to clear the way, you can clear the way. Next would be that there should be a sure closure backup. That is, no matter what has happened, there needs to be a mechanism where you can provide a sure closure if you choose to do that. And lastly, and very important for our industry colleagues, these blowout preventers need to be obtainable. They can't just be complicated drawings that lie on this. You have to be those that can really be built. And my understanding is that there's a significant backlog of orders on blow-up preventers today. And the question is, how do we get the requirements for blow-up preventers in phase with the production capacity for blow-up preventers? And so I would add, whatever turns out in the rulemaking, whatever turns out in design requirements, it'll be something that can be built and used by the industry.
I'm going to make a couple of comments here this morning about how the Department of Energy is partnering with the Department of Interior to take care of some of these challenges. I'll be approaching this from a couple of standpoints. First, as the person at the Department of Energy that manages the oil and gas portfolio, but also from my experience as the designated federal official for the commission, which was created by the President to determine the root causes of the Deepwater Horizon accident, and that had the unique challenge of trying to determine what went wrong while things were still actively going wrong. The first slide I'll just put up here is just a reminder for all of us. We talk a lot about safety, we'll talk a lot about energy security, about environmental sustainability, but also on the day that this rig went down, there were 11 American workers who did not return to their families. So all the work that we do here is not only about making sure that we've got a prosperous future for America, that we've got the right type of economic security and energy security, but also to make sure that we're taking care of the folks who work offshore doing this difficult and dangerous work. I'll spend just a couple of minutes talking through a slide that looks at some of the root causes that came out of the various investigations that have been made since the Deepwater Horizon disaster. This is one slide I will commonly spend half an hour talking to, and what I want to do here on this slide is just touch upon a couple things. First of all, as has been mentioned by a couple of the previous speakers, we're here to talk about one specific piece of this puzzle, which is the blowout preventer. And it's a piece of the puzzle that is very important and has rightfully attracted a lot of attention. But it is a piece that is interlinked with a lot of other complex factors that led to this disaster, the loss of the rig, and the subsequent oil spill. So what I'll do here is, I won't go through all of these items, but I'd like to touch just on how a couple of the items are specific to items which have been mentioned by previous speakers in terms of the BOP being an important key in ensuring that you prevent accidents. And as we all know, the best way to deal with accidents is make sure that you diagnose them and prevent them before they can occur. So in this long list of issues, from the design of the well through the testing of the cementing, through the changes in the abandonment plan, there are a number of items that are specific to BOPs. And one of them that hops out that actually was alluded to in a couple of comments that Dr. Hunter made was this inconclusive negative pressure test, in which you had one pressure reading on the drill pipe, you had a separate pressure reading on the kill line. There was that inconsistency, but also not, I guess, the process or the procedure or the safety mechanism to take that inconsistency, stop, and make a good decision around how that should be handled. So one thing to deal with here is organizational, it's cultural, it's procedural. But also there needs to be an understanding of how can we make gauges more reliable, how can we make them more robust. Even in the camping stack that was designed specifically to camp this well, one of the gauges, which was a brand new gauge, failed almost immediately. So this is something that is going to require some more work that we need to think about a bit more. A second point that I'll point to is this as another item that comes back to instrumentation, understanding what's going on at the seafloor, and ensuring that you're able to make good decisions in a real-time basis. So this is the last 2 hours of Sperry Sun data that came out of the Deepwater Horizon incident. And during the hearings that we held for the Deepwater Horizon during the commission work, we spent probably 3 or 4 hours looking at this particular chart and blowing it up, cropping it, rotating it, putting arrows. I mean, there are a lot of key signals in here that would help one understand that something is going badly. But what we don't have in place is something to help the person who's on the person who's running the drilling operation interpret this highly complex data set in real time and help those individuals make good decisions. So not only do we need to make sure that we are getting the right information from BOPs, but we need to make sure that we've got a good mechanism for getting that information up to the rig floor, and that we've got the right tools, we've got the right algorithms to help human beings make high pressure decisions based on voluminous but uncertain data. And the last thing is the failure of the BOP itself. So when the BOP was triggered, we know that somewhere between the annular preventer and the variable bore ram, that pipe was elastically buckled within the BOP in such a way that it was outside of the cutting surface of the blind shear rams. There's still a lot of discussion going on about exactly why that pipe buckled. I mean, as recently as the last hearing that we had for the Ocean Energy Safety Committee, we're hearing additional theories about why that pipe buckled. Is it pressure differentials? It was temper differentials? Was it rig drifting? So there's all sorts of ideas and theories about what caused the pipe to buckle. But one thing here is clear, that when we're looking at designing BOPs and also designing the procedures that the folks running the operations use to close in the well in case of a disaster, that we need to do a little bit more thinking about what are going to be the conditions under which the BOP is going to have to operate in an actual emergency. So there's lots of standards, there's lots of procedures in place to make sure that you're doing routine testing for BOPs, that you're opening them, that you're closing them, that you're ensuring that all of the instrumentation is working appropriately on an ongoing basis. And as we look at that data also, I mean, there are some concerns about the regularity at which you do see some failures within routine operations, but certainly something that we need to make some additional recommendations on and some progress, in my opinion, is ensuring that we understand the true failure states, the true conditions under which a BOP is going to have to act in an emergency, and that we're designing not only the equipment, not only the gauging and instrumentation, but also the processes and procedures in such a way that's consistent with ensuring that the BOP is able to actually avert an accident, avert an emergency in an actual emergent situation. So one of the challenges that we have in all the work we have in Washington is that there is, I think, this natural tendency, I think, to operate individually, operate in silos. That's something that can occur here. One thing I think that you saw was successful in this case is that you did have a seamless cooperation between agencies in which the Department of Energy worked together with the Department of Interior to make sure that we brought this to a successful conclusion. So one thing that we're doing within DOE to support the efforts here at the Department of Interior is ensuring that the research that we do within the Department of Energy is consistent with the challenges that the rulemakers have here at the Department of the Interior. We are a science organization. I've got the privilege of working under a Nobel Prize winning physicist at the Department of Energy. So we're clearly an organization that's dedicated to technology, that's dedicated to technological innovation. We're not the regulators, we're not the rule makers. But one thing that we want to ensure that we're doing is that we are designing our research programs and our processes, we want to make sure that we're doing things that are directly useful to the challenges that are faced by Director Watson here at BSEE and by the Department of the Interior. Another thing that was clear after the Deepwater Horizon accident was that we need to have an ongoing relationship, an ongoing collaboration with industry to ensure that the research that we're doing centrally to quantify these risks are consistent with the rate at which technology is moving forward, which means we need to have an ongoing work program with industry whereby we're using the talents and the capabilities of industry to ensure that we're keeping government informed and capable on an ongoing basis. I'll close with this slide that actually circles back to some comments that was made by Secretary Salazar in his opening. We talk a lot about all of the above, but one thing that I like to emphasize is this is actually not something new. This is a continuation and a consistency in this administration's approach to all of our energy sources. And so I'll point you to this top quote. I continue to believe that domestic oil production is an important part of our overall strategy for energy security, but I've always said that it must be done responsibly for the safety of our workers and our environment. This was a quote that the President commented back in April of 2010, shortly after the Deepwater Horizon accident. So this was a quote that was made while that well was still belching hydrocarbons to the Deepwater Gulf of Mexico. Capping stack had not yet been developed. Relief well was still probably months away. But even in that time, there was a realization that not only can we do this safely and reliably, but we must do it for the sake of our environmental sustainability and for our nation's energy security. So with that, I'll hand the podium back to Deputy Secretary Hayes, and thank you very much.
We're going to stay on schedule, but I am going to ask the panelists one key question, and then we'll set this up for the next panel, which will be led by Richard Sears, who, on behalf of the Presidential Commission that Chris just mentioned, did a heroic and very important effort in evaluating the root cause, and that's going to be a very interesting and informative panel. Here's my question to each of the panelists. Obviously, in order to come up with good design criteria for the next generation of BOPs, there needs to be close collaboration with the industry and with the manufacturers as well in terms of meeting some of the demands and criteria that Tom Hunter mentioned of actual buildability and feasibility, so that we don't have an academic exercise that can't be executed in fact. So my question to each of the panelists is how do we forge that cooperative relationship with the industry to ensure that whatever regulatory scheme emerges from this exercise, it can be implemented and it makes sense. Jim?
Yes, sir. Well, this is certainly a great start, and I think it's not the only venue that we have. And I was recently at one of the manufacturers of BOPs. I think there needs to be an exchange personally between the engineers and the inspectors at BSEE and between the designers and the fabricators of the BOP. You know, I think this is a dynamic thing which involves not just the original equipment manufacturers. It involves the customers, which is typically the drilling contractors, and then of course the operators, the lessees of the Outer Continental Shelf, who are bringing all of this technology together. And that's what we have here today. When we break up, we obviously have to continue that dialogue in more detail on a more one-to-one basis, and continually bring that back into a written form and distribute it out. Now, I'm pretty confident that our regulatory process does a pretty good job of that, but I think that quite often there's a need for more dialogue. And so we need to take advantage of the capability that we have in the modern internet, in the ability that we have to actually bring people into the Department of Interior on a regular basis. And I can tell you that that's one of my primary jobs, is to listen in my own office to the leaders of industry as we move forward with this. And then I would say, you know, lastly, we're in the we're building our organization still, so we're still bringing people in into our fold to actually do this engineering work, to actually write these regulations, who quite often are looking at a position in government coming from industry. And I want to emphasize that. I put it into my slides, is that we're trying to find the best talent in America, a portion of that, to actually work in the Department of Interior for the Bureau of Safety and Environmental Enforcement. I think that's also a very important part to getting this problem solved.
Thank you, Jim. Tom?
Sure, I'm on here.
Yeah, you're on.
I think it's a very important endeavor to figure out how to make this come out right in the end. I'll just list a couple of things which I think are important. First, the industry has a lot of cross-cutting organizations that can be very helpful and as an interface point with government. There are also engineering societies which have certain ways of looking at these problems that allow them to help with standards and design principles. But in terms of how to approach the problem, I would give a few simple things. Like first, get the framework right and keep it simple. Focus on the government side, particularly on what and not on how. And then to be sure that what is asked for is a system as opposed to some components, and keep the thinking at the system level. And then in line with what Jim said, I think it's very important for both the industry and the government to evolve the talent base that will deal with these problems now and in the future. So try to do everything you can to bring in good people and support good people in their development, and that's exactly what Jim mentioned. And one way I would close with doing that is to maintain, both within the industry and within the government, a vigorous R&D program which serves to have continuous improvement of both principles and operation.
Thank you. Chris?
Yeah, so I won't repeat what Jim and Tom said. I think they pretty much summed up, I think, the most important points. The one thing I would add is that this collaboration is a muscle that you need to exercise on an ongoing basis. And so you do need, on a real-time and ongoing basis, to make sure that you're doing real work together, you have a real collaboration, that you do have a real ongoing working public-private partnership, such that you're constantly remaining, I guess, updating the capabilities of government and industry to work together in these areas. So it's not something that we should be approaching as a SWAT team exercise when something goes bad. It should be something that's part of our ongoing way of doing business between government and industry.
Thank you. Thanks to our panel. And we'll now go to the second panel. Thank you.